Welcome to the classroom. Today we're talking about groundwater. We have a groundwater flow model that represents the real world. We have surface infrastructure like a septic tank, an underground storage tank. We have wells that we would use to actually extract groundwater for drinking water purposes or for industrial purposes. And we have different layers, all right, that represent layers in geology. At the very bottom, we have coarse aggregate, okay? That could be like your sands and gravels. And this allows the water to flow very easily through it. We call that layer an aquifer when it allows the water to flow easily through it. We also have areas where we have a clay layer, okay? These dark gray layers, they represent aquitards. And an aquitard is a layer that doesn't allow the water to flow through it. Clay actually has a very tortuous flow pathway. There's lots of pore space in clay or in shale, but the connection between those pores is very difficult, and it makes it a long flow pathway. So water does not flow through easily through our aquitard layers. So this well here, as well as this one and this one, are all below this aquitard level. And so this aquitard protects the underlying aquifer from contaminants from the surface. And so we'll watch the flow actually by injecting dyes into the wells and into the different infrastructure and see how the water flows through the different layers and how this aquitard protects the well down below. So without further ado, I'm going to inject some dyes into some of the wells, and we can actually watch the groundwater flow. The water should flow from the high side down to the low side where we have our river at the lower elevation. And we should see that flow from all of the layers. It just takes a long time for the water to pass through this aquitard at the bottom. So what I'm going to do is I'm going to inject some water into this well here. The filter at the bottom should show the water, the dye flowing towards the river. So let's have a look and see what happens of the red dye in this well. There you can see it really well. Now the red's flowing out over to the riverside. You can actually see in real time the water's flowing and the dye is being picked up and taken with that well. Now, if we were to have some leak from our septic tank, and this area here represents the weeper bed, which is actually the way a septic tank works. The solids fall down and the liquids go out into pipes underground and distribute the waste. And you can see the blue dye going over top of this clay layer, a little lens of clay. You can see the water's not flowing through the clay layer, but around it. And it's headed towards the lake and down, all right? So we would need to design our septic tank so that the contaminants actually don't flow towards the lake, but they actually flow deeper down, and the concentration gets dissipated as it moves away from the septic tank. So you can see the blue dye concentration. It's very high concentration over here, and there's a plume moving away, and we need to design it appropriately to avoid contamination of our groundwater. I can put some blue dye into this underground storage tank. You can see this plume also, the contaminants leak from that underground storage tank. It's moving down and over. So that represents the contamination and its transport on this unconfined aquifer. That means there is no clay layer blocking off this aquifer. So that means all of these wells, 2, 3, 4, and 5, have the potential to draw up some of this contaminant. If you see the blue plume from this underground storage is near the bottom filter of well 3. However, we could also use these wells actually to pump the water out and actually create a flow towards this plume area and try to contain this plume from exiting out towards the river. That is a way, understanding the groundwater flow regime and using our knowledge to actually try to clean up a contaminant flow. And also, potentially, we can move that contaminant by actually pumping water into the ground. So I'm going to inject some purple dye now into this well. If this represented a chemical that could react with this contaminant to neutralize it, we could actually do that also. Pump cleaning materials into the aquifer to clean up the contaminants that may exist there, and maybe we could pump from this side. So there's many things we can do to try to clean up the groundwater, but it takes a lot of effort. So the first thing to do is not contaminate the groundwater in the first place, and understand our geological environment, the different aquifer and aquitard layers that exist, and try to protect our groundwater that we use for drinking water, because it's vitally important for our survival. Thanks for watching.